Hello, my name is Michael Wood and I want to say a little bit about multiple regression and what it can be used for. So let's start off by getting rid of my horrible face, and the example I've got here is about selling houses, and as you can see we've got 10 houses, and there are, for each house we've got the house size, we've got the size of the garden, the location and the sale price. And obviously the question is, how do these variables impact on the sale price? Well, the first thought might be that houses in the town centre cost more, so the obvious thing to do is to work out the average house price in the town centre, which as you can see comes to 618. See the formula there on the formula bar. Similarly for the suburbs, and if you work out the difference, 165,000. So houses in the town centre cost 165,000 more than houses in the suburbs. Similarly for the size of the house. If we look at the spreadsheet here, what you should notice is that houses that have larger gardens, this is a scatter diagram of course, that's the garden size, the house size, and that is the price. So the houses that are larger here do tend to cost less than the houses here, which are a bit smaller and more expensive. So the correlation between the house size and the sale price seems to be negative. And if you look at the correlation which I've worked out there, that's actually the case. The correlation is minus 0.487, which is rather odd, isn't it? Because it seems as though the bigger houses cost less. But if you look at it in a little bit more detail, that's obviously because the bigger houses are the ones in the suburbs and the smaller houses are the ones in the town centre, and it's really the location factor that's responsible for the difference in house prices. So the question is, how can we disentangle the effect of the house size from the location? And the answer, of course, you've guessed it, is multiple regression. Now, multiple regression uses numbers. It's basically arithmetic, and words like town centre and suburbs don't go down very well. So we need to recode these as numbers, and the standard is to recode things as zeros and ones. So we'll let the town centre be 0 and the suburbs be 1. There we are. Wouldn't matter if you did it the other way around, of course. Next, you need to click on Data, which I've done already, then click on Data Analysis, and then click on Regression. If Data Analysis isn't in the menu, you need to install the Analysis Tool Pack. Now, it's now asking us for the Y range and the X range. The X range is the variables you start with, the Y range is the ones that you want to work out. X comes before Y in the alphabet. Alternatively, Y is the dependent and X is the independent. So the Y range is the sale prices, which is that lot there. The X range is all of this lot here. There we are. And if we now click on OK, we're now sent to another sheet, and the answer is here. So what we've got here is that just give ourselves a little bit more room. The most important answer is the so-called coefficients, otherwise known as slopes, for 3 variables. The first variable, remember, is the house size, and the coefficient here is positive. It's 0.049. Okay, so what does that mean? What that means is that each extra square foot of house size is going to add an extra $0.49,000 onto the sale price. So that's about 0.05 of a unit onto the sale price. As we're talking of thousands of dollars, that's $50. In other words, each extra square foot costs $50. So that's what the multiple regression prediction tells you. which of course is it might not be accurate, but it's a useful piece of information. Let's go for x variable 3. The coefficient here is minus 229. Let's think about what that means. Well, the third variable, 1, 2, 3, is the location. And what this is saying is that if you add an extra 1 onto the location variable, in other words, if you go from 0 to 1, if you go from the town centre to the suburbs, prices will go up by minus 229,000. In other words, they go down by 229 units. So the minus 229 is the impact on the sale price from having a house in the suburbs rather than the equivalent house in the town centre. In other words, houses in the centre, like for like, are £229,000 less than houses in the town centre. The suburbs are cheaper by that amount, which of course is a bit different from that 165. But the reason is that that is comparing houses of the same size and the same garden size. And this takes account of the fact that on average houses in the town centre are a bit smaller. Okay, so that's the way the slopes work. Just very briefly, if we go back here, the p-value tells you that that is obviously less than 5%, so in other words, that is unlikely to be chance. So that there is fairly definitely a positive impact of the house size, and similarly for the location. That is a lot less, that is a small number, which means that chance is unlikely to be the reason for that. On the other hand, that is fairly large, which implies that chance could be a factor. So that one, the first variable, and the third variable are statistically significant. The one in the middle isn't. And the other thing that's worth looking at is that the R-squared value is about 93%, 0.93, which means that this model accounts for about 93% of the variations between house prices. In practice, this is unrealistically high. For real data, you never get a number that high, but obviously I fiddled this toy data to make it show something interesting. In practice, multiple regression is only really useful for really big data sets where the R-squared value would typically be a lot lower. Okay, I hope that makes some sense, and I will now try and stop this